For the lesson 3, changing, repeating decimals to fractions. Take note, repeating decimals. Okay? Example 1, the given is 0.333. How many digits kept on repeating? Victor, how many? There is only one. Okay? There is only one digit keeps on repeating. How are we going to do this so that this repeating decimal can be changed to a fraction? Step 1, equate the decimal to a variable. I chose x for the variable. I equated the decimal to the variable x. So we have now equation 1. Step 2, multiply both sides of the equation in step 1 by 10. Why by 10? Because there is only one digit that keeps on repeating. So by 10, x times 10 is 10x. 10 times 0.3333 equals 3.333. Step 3, subtract equation 1 from equation 2. So this is the equation 1, subtract from equation 2. So 10x minus x equals 9x. 3.333 minus 0.333 equals 3. Okay, to find x, 9x over 9 equals 3 over 9. Lowest term of 3 over 9 equals 1/3. So what do you notice? What do you notice with the fraction not in lowest term? Without doing the steps, how can we obtain this? So you have just to remember this. If there is one repeated digit in the decimal, okay, copy the digit once. And then for the denominator, use 9. In this case, 3 over 9 is not simplified. So I reduce it to 1/3, the lowest term of 3 over 9. So remember, if there is one digit that keeps on repeating, change that to a fraction wherein the numerator is that repeating digit, and then write the denominator 9. Okay? What about example 2? For example 2, 0.4242, there are two digits that keep on repeating. How are we going to change this to a fraction? Just like what we have in example 1, equate the decimal to a variable. So I use x for the variable. This is our equation 1. Step 2, multiply both sides in equation 1 by 100. Why by 100? Because there are two digits that keep on repeating, and 100 has two zeros. Okay? So multiply by 100 both sides. 100 times x or 100x. 100, 0.4242 is times 100 equals 42.42. This will be the equation 2. Step 3. Substitute equation 1, subtract equation 1 from equation 2. So you have now equation 1, equation 2, subtract. 100x minus x is 99x. 42.4242 minus 0.4242 equals 42. Okay, to find x, we have divide both terms by 99, so that what is left is 42 over 99. Look at the answer. This means that the given 0.4242 is equal to 42 over 99. This means if two digits kept on repeating, to change that to a fraction, write the two digits in the numerator and 99 in the denominator. If the fraction form is not yet in the lowest term, so you have to reduce it in lowest term by using GCF. And the lowest term is 14 over 33. This is the fraction of the repeating decimal in simplified form. Okay? For example number 3, I have 0.123, 123, 123. So there are three digits that kept on repeating. Step 1, equate the decimal to a variable. I use x for this. Step 2, multiply both sides by 1,000. So times 1,000. Why 1,000? Because there are 3 digits that keep on repeating. And 1,000 has 3 zeros, 3 decimal places. So that 1,000 times x, 1,000 x, 0.123 times 1,000 is 123.123. For step number 3, subtract equation 1 from equation 2. So that equation 2 minus equation 1. So 1,000x minus x is 999x. 123.123 minus 0.123 is 123. Therefore, x is equal to 123 over 999. Not yet in the lowest term. Is equal to 41 over 333, the lowest term. Okay? What do you notice again? Okay, 3 digits which are repeating. You write to change the to a fraction without doing the steps 1, 2, 3. If you know the concept of doing it, and then now you discover that it is like this. So you copy the 3 digits that kept on repeating as the numerator. And then for the denominator, you write 999. Okay, the proof is what we have here in step 1, 2, and 3. But this fraction is not yet in simplified form. So we have 41 over 333 in simplified form. Okay, after you copy the example 1, 2, 3, I still have 2 to 3 more examples about lesson 3. We are still on changing repeating decimals to fractions. This time, there are, in the decimal, there is, in number 4, there is a digit that is not repeating, which is digit 8. Only digit 3 keeps on repeating. So how are you going to do this to change this decimal to a fraction? Step 1. Subtract the repeating digit from non-repeating digit. Which one is the non-repeating digit? 0.88. So you write 0.8 minus the repeating digit, 0.3. So 0.8 minus 0.3 equals 0.5. Then, for step number 2, add the result in step number 1 with the repeating digit. Change them first to fractions, then add. So this is the result in step number 1 plus the repeating digit. Change it decimal here to fraction. So we have 0.5 is equal to 5 over 10, and then I can reduce it to 1/2. Okay? And then 0.033 is a repeating decimal. Remember, 0.003 is the same as 3 over 9, which we learned in the previous first 1, 2, 3 examples. So remember this. I told you that if there is a repeated one digit, you write it as a fraction, copy that the repeating digit in the numerator, and for the denominator, write 9. And then, this 3 over 9, I can reduce it to 1/3. But I could not add 1/2 plus 1/3 because they are not similar. So we have to use the LCD to change them to similar. And the LCD is 6 between 2 and 3. So changing 1/2 to 1/3 to similar fractions, they are now 3 over 6 and 2 over 6. So that 3 plus 2 is 5 over 6. So that 0.8333 is equal to 5 over 6. Understood? Okay. example number 5. In example number 5, there are 2 digits which are not repeating. Only 1 digit keeps on repeating, 4444. So what are you going to do? Step 1, subtract the repeating digit from non-repeating digits. Okay, the non-repeating digits are 6 and 7 minus 0.44 or simply 0.44. Then subtract the 2, the result is 0.23. Step number 2, add the result in step number 1 with the repeating digit. Change them first to fractions, then add. So the result in step 1 is 0.23. In fraction, that is 23 over 100. Okay? Then, for the repeating this digit, you have 0.44 equals in fraction, that is 4 over 1 over 9. And then, look for the LCD since we cannot add them since they are dissimilar. The LCD is 900. So 900 divided by 100 is 9 times 23 is 207. 900 divided by 9 is 100 times 4 is 400. Add the 2. 207 plus 400 is 607 over 900. Therefore, the fraction of 0.6744 is 607 over 900. What about example number 6? So, 0.377. There is only 1 digit that keeps on repeating. Step 1, subtract the repeating digit from non-repeating digit. This is the non-repeating digit. This is the repeating. The answer is a negative 0.4. Don't be afraid if the answer in step 1 is negative. Add the result in step 1 with the repeating digit. Change them first to fractions, then add. Okay, so this is the result step 1. Negative 4, negative 0.4. In fraction, that is negative 4 over 10. You can simplify it, that is negative 2 over 5. Plus 0.77 is the repeating. In fraction, that is 7 over 9. Equals 7 over 9. Change them to similar fractions. That LCD is 45, 45. 45 divided by 5, 9 times 2, 18. Still it's negative. 45 divided by 9 is 5 times 7 is 35. Since 1 is negative, subtract the numbers. 35 minus 18 is 17 over 45. Okay, copy the sign of the bigger absolute value, positive. So 0.3777 is equal to 17 over 45. Did you get? So easy. Question? Okay, very good. You understood because you listened very well. Copy now. Copying time.